another approach in which we will see that how the minimum falling path sum we will calculate through not the brute force and not through the another top-down approach of dynamic programming, but we will go through now bottom-up dynamic programming. Okay, so in this technique, right, we will use the memorization technique and followed by the top-down approach, right? So we will start by finding the result of original matrix, and recursively we will move towards computing the result of a smaller subproblems. So there is yet another technique to implement dynamic programming problem, that is called bottom up, right? Top down and bottom up. So this one is bottom up dynamic programming, as known as tabulation. So in this bottom up approach, we will start by finding the result of a smaller subproblem, and iteratively we will move towards large subproblems. So being non-recursive in nature, this approach does not require maintaining a separate internal call stack for storing the intermediate state for recursion. So the result of subproblems are stored into the dimensional DP. Here the smallest subproblem would be matrix with only one row. Thus we will first calculate the result for each cell in the last row, that is called base case. Call this nth row and store the result in DP. So next we will move to n-1 row, and result for the next row will be in the nth row. We can say that's already we have present, right? So in this way, in the every iteration, we are calculating the storing the result for the subsequent problem. And while this approach doesn't improve, right, the time or space complexity of the top-down approach, it does act as a stepping stone toward the next approach, where we will improve the space complexity for the we'll see the approach 4 also, and we will optimize the space. So algorithm for the bottom up dynamic approach will be the bottom up dynamic programming follows an iterative approach to solve the problem. We have to start by finding the minimum falling path, right, of sum, and that is for the we will move into the possible matrix. Matrix having a single cell, and one by one we will move towards the rest of the cell in the matrix. So first step, what we will do, we will give me 1 minute of pen. Okay, so we will start with the step 1, in which we will see how to do to compute the minimum falling path for certain row and column. We must have to pre-computed value for the minimum falling path for cell row plus 1, column minus 1, row plus 1, column, and row plus 1, column plus 1, right? Means three things we have, three possible path we have, right? That should be pre-calculated. And for this we will iterate n-1 row to 0 row, right? We will start from the last row, that is n-1 to the first row. Okay, from 0th column to n- column, right? Similarly, we will build what 2D matrix DP and compute the minimum falling path of row and col. So there will be a DP, right, of row and col, in which we will start with row plus 1 and column minus 1, row plus 1 column, and row plus 1 column plus 1, correct? So plus the value of the current row and column in the matrix, right? 4 things we have to check, and we have to do add. Okay, next we must have to handle the edge cases. For example, if the column is 0 or n-1, this is our edge cases. Okay, so once we have the minimum falling path for every cells, we must get the result from the start cell, and the cell can be any cell on the first row, and thus we will iterate over the cells in the first row and return the minimum value. So how we will start, right, the row? So let's understand, if this is our matrix, right? So we will start from here, right? So we will calculate, we will do sum from here, this one, right? If this is a matrix, so we will calculate from here, then here, and then we will move to the top one. Okay, we will do, that's why it is called bottom up approach. Okay, bottom approach. Now initially we will take a DP, right? Here we will take a DP of array that have that size matrix length plus 1 and matrix length plus 1, right? In which we will take one extra length. Okay, now we will start from row, which row? The last one, right? Because we have to go from bottom, right? We have to go from bottom. Previously we are starting from what? Index row 0, and then we are going to n minus 1, right? That is length minus 1. Then we have to start the last length, and we will go to the row, first row, right, till row is equal to 0. This is row that we have 0, and this is the row we have length minus 1, n minus 1, you can say. Okay, in the decreasing order. Inside we have column 0 to length, right? So column is always will be what? This is the first column, right? And this is the last column. Okay, so this column is what? 0, and this is n. So this loop should be in the increasing order, correct? This loop should be in the decreasing order, and this loop should be what? In decreasing order, increasing order, decreasing order, increasing order. Now we will do the base cases, right? These are the base cases that we already know. So if column equal to 0, right? If column equal to 0, we will calculate row and col, right? Row and col. Okay, so col equal to what? 0 means we are at the column 1. Okay, so row and col, then we will calculate the dp row plus 1 column, row plus 1 column, row plus 1 column, and matrix row column. Okay, in which whatever the minimum we have, right, that we will come, right? So we have row plus 1 and column, and we have row, column, and matrix row and column. Means if we talk about this row plus 1, means we are going to this one, right? We are going to check this one, this row, row plus 1, and column will remain same, column will remain same. Next we will move to which direction? Row plus 1 will remain same, but we will go either this direction or this direction, right? Will remain the same position. So we will do sum of this value to this value and this value, whatever the minimum value we have, that side we will move. Similarly, if we reach to the edge cases, next base case, matrix length minus 1 column, then we will calculate dp of row and column. That should be a minimum of what? Row plus 1 column and row plus 1, but we will move to column minus 1. We will move to left side, and the value of the matrix will calculate, right? Okay, and then finally we will, what we have dp, right? We have dp, in which we will see the dp of what? 0, and dp of what? Minimum, we will calculate the minimum, and the minimum of what? This one and this one. Okay, and final this one. Okay, so always you can see that we are using this one, right? We are calculating the dp of row 0 and column, in which we are passing minimum, we are checking the minimum, right, between row plus 1 column minus 1, row plus 1 column, row plus 1 column minus 1, column plus 1, and then we will storing what? The value of the current row in the matrix, correct? And these are the edge cases. Edge cases is this one, and this one the edge cases, right? So always we have to what? At the edge cases we will calculate how? Row plus 1 column, and between row plus 1 column plus 1, right? We will increase one more row, right, in the column plus 1. So in this we have to check which one is minimum, and then we will store, then we will add what? The current column. And if we have what? Minimum between row plus 1 and column, and row plus 1 column minus 1, in this whatever the minimum will be, that we will add into the current one. And similarly for the row and column, we will check row plus 1 column and row plus 1 column, in which whatever the minimum we have, right, that will come, right? Row plus 1 we will see, and row plus 1 column plus 1, in which one is minimum, that we will come, and after that we will check this one. So in this you can say row plus 1 column, row plus 1 column plus 1, and column plus 1 column minus 1. In 3 we will get the minimum, and then we will add into the current, right? 3 things. And finally we'll get what? We will initialize our mean following sum. We have to take minimum, in which we will start the index 0 to the last length, and we will check all the dp value, which one is minimum, that will come to the minimum path sum, and then we will return that minimum sum, right? So in this you are seeing that what we have on square, right? What we have on square, and because we are moving multiple times, we are looping the each node we are moving by two way. So we have nested loop for the for n square time to fill the dp array, and then takes n time to find the minimum falling path. And so that on square plus on is what on square, and that should be the our time complexity, and the space will remain the same because dp of size of n square we have, right? So we'll see the optimized way in which we will see the approach for the space optimized bottom up dynamic programming, okay, in the next video.